Okay, I'll get a pointer. Okay, what I'm going to do today is talk about modifying tree canopies, and the specific example I am going to use is olives. This picture was taken at an early morning mechanical harvesting experiment when you in Visalia, near Visalia in Tulare County in California. When you work with mechanical harvesting and pruning, you get to see a lot of early morning sunrises. Okay, and that's to tell you we're working with California olives. There are only two reasons to prune a tree. The first is to get even annual crops, and specifically to decrease alternate bearing. The second reason is harvestability. How much of that fruit can you actually get into the catch frame or the harvest bin? Otherwise, these trees grew just fine without us until we developed these two issues. Okay, this is an example of what we want in olives, getting them into the harvest bin, maybe with not so much purple. Okay. So there are two olive industries in California. The first is the table olive industry. This is a traditional table olive tree. Olive trees can routinely be 40 to 60 years old in California. That's an 18-foot ladder. This is the current major method of harvesting, and it is absorbing approximately 50 to 60% of our gross return. We get about $1,200–1,300 a ton for the best quality olives. We get we shoot for 5 tons to the acre, and it's costing us $600 to $700 to hand harvest and haul these olives, 50 to 60% of our gross return. This is our other olive industry. This is the oil olive industry in California, moving toward high density, 200 to 300 trees per acre, or super high density, up to 800 trees per acre. This crop is mechanically pruned and mechanically harvested. Harvesting costs about 15% of gross return. Again, we're shooting for about 5 tons to the acre. Okay, so basically we're trying to adapt our table olive industry to see what we see in the newly developing oil industry, which was a result of genetics for oil. This is the kind of situation we have in California, or basically now we're down to 14,000 acres of our major cultivar, Manzanillo. And down here near Terabella, 1% of our crop was pulled out in favor of higher producing pistachios and almonds. So our industry is largely decreasing, and this is the reason. It's these fellows. They are no longer as available as they used to be. They definitely aren't as affordable as they used to be. And having close to 35 years in the industry, I can tell you these are not the pickers I knew 35 years ago that could pick a ton per acre. So this is the California table olive industry has its back up against the wall in terms of maintaining a sustainable crop in production costs. Now, when you go to modify orchards, when you have an existing industry, you have to deal with 3 types of orchards. You have to deal with your existing orchards in the ground. You can't pull out your whole industry, especially when it takes 3 or 4 years to come into bearing. So these are trees that the size must be reduced. Younger orchards, perhaps you can catch them and maintain the size. New orchards, size can be dictated because, as Mary Lou pointed out with avocados, and as we have with the oil industry, genetics produced a smaller tree, and that's the reason that industry is moving toward moderate density, high density, and less so super high density, because canopies are hard to maintain because they can be mechanically pruned and mechanically harvested. So let's talk first about the existing traditional orchards. If we, even for hand harvesting, much less mechanical harvesting, the size simply must be reduced. Like I said, this is the tree. They were up to 30, 35 feet tall, okay? And as they get much old, in terms of trying to mechanically harvest them, As they get much older, they have larger and they have more irregular trunks, which also dictates the form of mechanical harvesting we're going to develop because of the size and shape. Now, one of the big mistakes that's always made in mechanical harvesting, and we were no exception, is that people try to develop a harvester for the tree they've got. One of the things we learned is you modify the tree and you develop the harvester simultaneously. So this was one of the first monsters we developed for mechanically harvesting olive trees in California. It had 3 heads like this that had sets of free rotating rods with a horizontal whip at the end of each of these rods, which whipped against the branches and dropped the fruit into the catch ring. A pair of these machines would move down, compress the canopy for better removal, and the fruit would go into this bin. Okay. Here it was in action. I can tell you right away that this tree not only removed olives, it literally pruned the trees. We've discovered very quickly if we were going to do any mechanical harvesting, we had to reduce the size of the trees we had. And as I said, the thing we learned was there is no mechanical harvesting without modifying the canopies. So I started with those trees. I took it in 2 steps, and this is showing you step 2. I lowered the trees by 10 feet first with this kind of harvester, a swirling head that had individual saws. And then in step 2, we took this tree down to 11 to 12 feet. We then went in and hedged the sides approximately 4 to 6 feet from the trunk, okay? And over an 8-year period, these were a moderate density even for table olives. Originally, table olives were more like 96 trees to the acre. This is 139 trees to the acre. This hedging and topping experiment basically took the trees down to approximately 40 to 45% of their original volume and kept track of the average annual yields over a 5-year period. Yes, 2008, a 5-year period. There was 1 more year of data. On the old traditional trees, but I'd only taken down 1 step, I got 5.3 tons to the acre, right about where we want our, and that's average per year over the 5 years of the experiment. Whereas the mechanically pruned and topped trees got 4.2 tons to the acre and harvested, I'll show you the harvester, with 92% more efficiency than these with the mechanical harvester we developed. So basically, the loss of yield was made up for by the harvesting efficiency. Now, because these trunks were large, again, and irregularly shaped, we had to invent a harvester. And what I did was take the technology from our earlier experiments and the engineers, rather. I helped with it, but the engineers designed the machine. And we produced this head that could be mounted on a bobcat. This is a prototype, and basically could be continuously driven down the modified tree row. So we had the advantages of continuous harvesting plus accessibility to the canopy. With all prototypes, of course, you can't develop a final machine. So I'm just showing you how we collected the olives. We basically took that bobcat mounted head and drove it backwards, catching the olives here, okay? So that's what we did for the existing traditional orchards. We basically designed a machine and just decreased the size of the tree with mechanical pruning. What we found with the mechanical pruning was height is controlled by topping and size, light interception by hedging. We also found that for good light interception, you must include some hand thinning cuts to let light inside that canopy. Okay, now we also had younger orchards, some in the 10 to 15-year range. These orchards had manageable trunks. So again, what we did, first, we basically went in and did some hand thinning to select the more upright scaffolds. One, because when I'm going to show you the type of harvester that we adapted, we needed a clear trunk. And two, the kind of harvester we used has better removal when you have a more vertical scaffold. So we hedged and we topped these trees at approximately 12 feet again and 6 feet from the trunk. And we skirted the trees mechanically at about 4 feet, because what we used was a modified pistachio trunk shaking harvester. These younger trees had trunks that we could still pad the shaking head sufficiently that it wouldn't harm the tree unless there was bad operator performance, because that's one of the ways you usually get your tree barking is from the operator. So what I'm showing here is with some of our younger trees, we were able to access a harvester already available in the industry, change the angle on the wings a bit, change the size on the shaking head down here, and use this machine. Here it is in action in an orchard. And basically these were almost up to moderate density at 180 trees to the acre. It costs us about $1,000 an acre to initially prune them. And thereafter we had to top them every year. I'll explain why in a minute, and hedged every other row middle every other year. When the operator got very good at using this machine, it was about 30 to 40 seconds per tree, 90 to 190 trees per hour. So we were getting 2 tons per hour. And one of the battles we had to fight was, is this fruit acceptable at the station, at the grading station? This is the mechanically harvested fruit, and here's the hand harvested fruit. One of the aces in the hole we have with the California table olive industry is we do black ripe processing. It hides these small, I'm looking for one up here, small nicks on the fruit, okay? So the third is new orchards. Size can be dictated. As I said, this is the reason we have an oil olive industry, because in Spain, they developed young olive trees that have the genetics for dwarfing. But there's also another way. This is a 202 trees per acre orchard, about 12 by 16 that we developed in Yolo County, California. It is that same variety, the Manzanillo variety. But what we did was decide to raise the tree on a trellis, okay? And what we did was put wires at about 4, 6, and 8 feet here. This is now when the trees are about 7 years old. But we put these end posts in, and on a 30 tree row, we had 1 middle post. We strung the 12 gauge wire at about 4, 6, and 8 feet. And then we had 3 different treatments in this row. We had 10 trees that were raised the way we usually raise olive trees. We had 10 trees where the consultant trellised the tree by tying to the horizontal wires. And what I chose to do was, as the branches came up, I wove them through, when they were still flexible, I wove them through the wires in a palmate fashion on both sides of the central leader, which we topped. So what we did was essentially develop a 12-foot tree that was 6 feet wide, skirted up about 4 feet, and about 202 trees to the acre. This was using the tree we already had. It has no special genetics for dwarfing. In the row, what I did was snake those branches as they grew between the 3 wires. So it had a 3-point it was secured at 3 points, and I raised it in a palmate fashion. This is looking at the tree from the side. So what I tried to do was take advantage of the tree's natural branch angles, but make the branches extend into the row, not into the row middle, but into the tree line. Any branches that came out into the row middle, we removed, okay? Then as the trees got more mature, we started exerting mechanical pruning, okay? So here's what I did in 2011 at about 10 feet and about 2 feet from the trunk. The following year, I topped it again at 11 feet. We had crop on one side where we didn't prune. Olives bear on 1-year-old wood. So you grow the wood this year, the olives are produced the second year. So wherever I pruned the previous year, there will be crop 2 years later. So over here on this side, this is going to be the crop. We're now in 2012. This is the crop in 2013. This is in 2012 where I did a cut for crop in 14. And over here where it was pruned in 10, it will have crop in 12. Following year, there's my crop. There's where I pruned it the year after it had crop. And up here will be the 2014 crop. Again, the beauty of this system is we could use a canopy contact harvester that could move continuously down that fruiting wall. But the only problem with mechanical harvesting, I'll say this right now, is that it is indiscriminate. There is no color picking. These dark purple olives do not process well. So one of the things that we have started to do, I'm going to go back one slide, in maintaining an orchard like this is we top annually because the fruit up here tends to ripen sooner, both for table and oil olives, and bring the grade down. So we're now using topping in both olives and pistachios totally for size control. We don't harvest the fruit on the top. We're interested in the fruit that's on this vertical canopy, which of course means we space the canopies. So if you grow a tree in a northwest line, you don't want the canopy as the sun goes east-west. You don't want the canopy to shade the adjacent row above the bottom of the canopy, both above the bottom of the canopy, because you want to get all this fruiting wall, okay, to eliminate this purple in the bin. So just to show you some of our results here, we produced that kind of canopy with hand pruning, got 3.7 tons the acre and 80% harvest efficiency. With the mechanical pruning and harvesting, we got 4.3 tons, 81% harvest efficiency. Again, this is over 6 years. These are average yields, okay? So our mechanical harvesting and pruning summaries goes as follows. With trunk shakers, with young trees that we could modify, we could get marketable olives that consumers could not tell the difference between hand and mechanically harvested olives. And the good thing here about the young orchards or the hedgerow orchards was that the shaker was commercially available. When you do mechanical harvesting research, the hardest thing to do is get a fabricator to make your machine. With the canopy contact harvester, in the hedgerow trees and in the modified, much older, larger trees, our efficiencies range from 80 to 92%, which was enough to met our previous efficiencies and costs with hand harvesters. Again, the fruit was perfectly marketable, had the same grades at the receiving station, and once processed, consumers couldn't tell the difference. But with this canopy contact harvester, even though we designed a small head that would only cost about $50,000, made the specs available, no manufacturer has yet fabricated it. We still have a prototype. And as a result, that kind of harvesting has not been adapted. Now, the oil industry. The oil industry in California is booming. It's gone up to almost 45,000 acres in the past decade. It's all due to the genetics that allowed these super high density, and moderate density orchards to be planted, mechanically pruned and mechanically harvested. What we have found is that the super high density orchards are a little bit too hard to maintain, and they're moving back to the more moderate densities, 2 to 4, more like 400 trees to the acre. They're still able to top for height for the straddle harvesters and hedge very lightly on the sides. The topping is annually. The side hedging is biennial, every other row, every other year, in combination with hand cuts. You must have hand thinning cuts to increase the light penetration in the canopy. And this is how those trees are raised. They're basically raised as single leader trees on a wire with branches, again, put on one or both sides. There is no tying of the branch to the tree. We basically simply allow the wire and a bamboo stake to hold the tree upright and try and arrange the branches so they fall on either side of the tree, but not coming out into the tree row, which enables them to use these straddle, what we call bow rod harvesters that vibrate these taut sets of rods under the tree. And by the way, these harvesters were adapted from grapes, which is another reason the whole industry was able to change so quickly. So in conclusion, if you're after changing a tree canopy, the first thing you have to consider is, what are you trying to do? Why are you changing? What's your goal? For us, with the California olive industry, it was simply we had to reduce our two biggest inputs, pruning and harvesting. We had three industries to work with: the existing traditional orchards, where we worked with reducing the size. That's a short to midterm solution. We worked with young orchards, where we maintained the size. That is a midterm solution. And with the oil industry, with the table industry, we also produced new orchards. Even though we didn't have the genetics, we basically used pruning to keep the size down. It's still in its infancy. We don't know how long-term a solution it will be. The oil industry had, as Mary Lou pointed out, genetics to make a smaller tree. And I want to point out that there is no developing mechanical harvesting or cheaper harvesting, if that's your goal, without adapting the canopy at the same time. Basically, the canopy management gives you size, and the mechanical pruning or mechanical canopy management dictates the size of the tree, both height and width. Hand pruning is what you need for light interception. And with that, I'll close and take questions, and I'll stop sharing.
Louise, we have one great question.
Sure.
When you speak of harvesting efficiency, what comprises the efficiency factors that you're alluding to?
Okay, when we speak of harvesting efficiency, the way we did all our experiments was we would basically run the harvester down the tree row and get the weight and grade on the bin. We would go back and collect what was on the ground, and we would strip what was on the tree. So we added those three weights together: what's in the bin, what's on the ground, and what's on the tree. And that became the denominator. We divided then what was in the bin by those three sums. So harvest efficiency is a function, is what you got into the bin divided by what was on the ground, what's in the bin, what's left on the tree. And it's also qualified by the quality of the three. Of course, what's on the ground gets a little scraped up, but often what's left on the tree is smaller fruit and lesser grade. So we did it by value per ton of what was left on the tree, value per ton and quality, percentage left on the tree, percentage dropped on the ground, and percentage that made it into the harvest bin. So in the end, it's total fruit on the tree, it's fruit in the bin divided by total fruit on the tree and graded.
Thank you, Louise. So we have two quick questions and we'll move on to the next speaker. One is the rows have north-south. The ideal row orientation is north-south.
The ideal row orientation is, I'll stop sharing here, is, oh, I stopped sharing, I guess. No, ignore me.
You did.
I did stop sharing. Okay. I managed to get myself back into share, so I will stop sharing it. The best row orientation that we found is north-south And then depending upon the height, 10 to 12 feet, what you're trying to do is maximize that sun on the vertical canopy side. So it differs with your latitude, the spacings that you can use. There's a fellow named Connors who's done some very nice work, and a fellow named Rosati, not Rosati, fellow in Argentina, oh, blanking on his name right now, who've done some nice work determining how far the rows have to be separated at different latitudes to not shade the canopy, because it's been pretty well demonstrated that yield decreases as you go lower in the canopy. One thing going to hedgerows has demonstrated to us is inside that olive tree, there is just a lot of wasted tree canopy because it's not bearing. And the leaves inside aren't even that effective photosynthetically, so they even aren't giving that much of a carbohydrate resource to the tree.
Thanks, Louise. That sounds like an avocado tree. So we have, I think we'll just take one more question, and I see Ken Hassett has his hand raised. So Ken, do you want to ask your question?
Yes, Ms. Ferguson, I am actually in Southern California, in Camarillo, California. Are there olive varieties that do well in my area?
Olives, unfortunately, it would depend upon your altitude. Olives, unfortunately, have a chill requirement of about 400 hours below 45 degrees Fahrenheit. And if you don't have adequate chill, you're not going to get a crop. In the Mediterranean, they developed with intermittent periods of glaciation. So even though they're a subtropical, they have a chill requirement. So
I will ask for your contact information so I can privately
sure.
consult you. So
Sure.
I don't want to take other people's time. I appreciate it very much.
You're welcome.